Modern climate change begins with the physics of energy flow into and out of the Earth's system. Three interrelated concepts, energy balance, the greenhouse effect, and radioactive forcing, explain why the planet is warming. This lecture is extremely important. Let's examine each in turn, starting with Earth's energy balance. The Earth receives energy from the Sun, primarily in the form of shortwave solar radiation. On average, about 340 watts per square meter of solar energy reaches the top of the Earth's atmosphere. Of this incoming energy, roughly 30% is reflected back into space by clouds, atmospheric particles, and the Earth's surface. This phenomenon is known as albedo, and the remaining 70% is absorbed by the Earth's atmosphere, land, and oceans, warming the planet. To maintain equilibrium, the Earth emits energy back into space in the form of long-wave infrared radiation. When incoming and outgoing energy are balanced, the climate remains stable. However, if more energy is retained than released, even by a few watts per square meter, the planet will warm. Moving to the second concept, the greenhouse effect. This explains how energy is retained. Certain gases in the atmosphere, known as greenhouse gas, or GHG, allows sunlight to pass through but traps some of the outgoing infrared radiation. This keeps the Earth's temperature approximately 33 degrees Celsius warmer than it would be without the atmosphere. The most important naturally occurring greenhouse gas is water vapor, followed by carbon dioxide, methane, and nitrous oxide. These natural greenhouse gases is essential for life. However, human activity, especially the burning of fossil fuel, have significantly increased the concentration of long-lived greenhouse gases in the atmosphere. This enhanced greenhouse effect is the primary driver of the current global warming. The third concept is radiative forcing. This measures the change in energy balance caused by the changes in atmospheric composition, land use, or solar output. It is expressed in watts per square meter and tells us whether the climate system is gaining or losing energy. Here, there are two types of radiative forcing, positive and negative. Positive leads to warming. It occurs when there is an increase in GHG concentrations or other factors that traps more energy. On the other hand, negative leads to cooling. This can result from aerosols or increased surface reflectivity, such as from snow or ice. Since the industrial era, net radiative forcing has always been positive, largely due to the rising levels of carbon dioxide and other greenhouse gases. This imbalance is what drives the long-term warming trends observed in global temperatures, sea level rises, and other climate indicators. So for the exam, make sure you understand these three concepts, and importantly, which they often test, is what are the implications of positive and negative radiative forcing. Remember these two concepts, and you should be able to answer the questions in the exam.